So today I'm participating in Biweekly contest 75. And I'm registered. Let's see the first problem, which is minimum bit flips to convert number. Hmm. Okay, so a bit flip of a number is of a number x is choosing a bit in binary representation via flipping 0 to 1, 1 to 0. Cool. Minimum number of bit flips required. Isn't this simply the XOR? Uh, Wait a minute. I think this is simply XOR. And then you take how many bits are in the XOR. Is it? Not sure. So from 10 to 7, it's in three steps, 3, 3. Answer is correct. Yeah, I'll make a summation. Yeah, this works. Okay, so second question. Find triangular sum of an array. Right, so given a zero index array, okay, every number is a digit between 0 to 9. Triangular sum of numbers is the value of the only elements present in after the following. Okay, so this is I think the process. You sum these two, it's 3. You sum these two, this is 5. Okay, cool. This way. Okay, um you only take the digit after remainder of 10. So this is 16, so you only take 6. You ignore the 1. Correct. Hmm. Okay. Since length is not too much, can I do you know, a brute force kind of a thing? Yeah, I think so. Okay, I'll make a copy of it. I'll make a copy of this in this B, and then while B dot size is greater than 1. Okay, so I'll make a new vector int C. Cool. So for int I equals 1, I less than int B dot size I plus plus C dot push underscore back B of I minus 1 plus B of I mod 10. Correct? So you do this. It's not B, it's C. And then finally you assign B equal to C. You return B of 0. I think so. This should be the approach. Hmm. 8 and 5. 8 and 5. Yeah, seems this works. Okay. Accepted. Third problem. So you're given a zero index binary string S, which represents the types of building along a street. SFI0 means an office. SFI1, it means a restaurant. As a city official, you would like to select, okay, three buildings. Mhm. How to ensure variety? Not consecutive buildings. Another selected buildings can do same type. Correct. Mhm. Return the number of valid ways to select three buildings. Okay, so we want to select three. So if we say three, and they're saying no to consecutive should be same. Okay, so we're going to select something like 0, 1, 0, or what? Or 1, 0, 1? Is there any other possibility? I don't think so. So yeah, these two are the only possibilities. 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 1, 0, 1. Cool. So yeah, these two are the only possibility. Um, how do we do this? So for everyone, we find out, okay, how many zeros before it. Got it. So this is my answer. Now I will let us hint prefix of n plus 1, 0. So this tells me number of zeros. Okay. Now, how do I do this? Prefix of 0 is equals to s of 0 equal to 0. Then after this, I equals to 1, I less than. I should take n also. N is the size of string. Okay, so I go till n. So I say prefix of I equals prefix of I minus 1 plus s of I equals 0. Cool. So now uh, int 0 equals 0. I'll start from the right side. I equals n minus 2 because n minus 1 is useless till greater than 1, I minus minus. If s of I equals 1, else this is the case. Answer plus equals s of n minus 1, sorry, equal to 0. Okay, so if it is 1, I want to know how many zeros are ahead of it, which is number of 0, and I should say this is long. Number of 0 ahead of it into prefix of I minus 1. So this is the number of zeros before, um, number of ones after it. So how should I say that? N minus 1 minus I, okay, minus 0 times something. Something is what? If I'm standing at position I, there are I elements before me, minus prefix of I minus 1. Hmm, seems okay. Let's call it long. Hmm. This seems okay. Run code 2 and 0. 2 and 0. This is wrong. Why? Okay, this should be 4. No, that is correct actually. So n minus 1 minus I. So if I'm starting at n minus 2, this will give me 1. Okay, I'm not appending anything. If okay, 0 plus equals s of I equal to 0. 6 and 0. It seems good. I'll make a submission. Accept it. Okay, cool. Last problem. So you're building a string s of length n, one character at a time. Perpending each new character. Okay, prepending, sorry, each new character to the front of the string. The strings are labeled 1 to n with the strings with length I is labeled s of I. Hmm. Okay. S1 is this. S2 is the A. Is it the suffix? Got it. The score SI is the length of longest common prefix between SI and SN. Hmm. Okay. Longest common prefix between this and this, between this and this, between this and this. Longest common prefix. I can do this using hashing, but there should be a more elegant way. Hmm. Okay, wait. So for every string, I can do a binary search or something like, but isn't this something like a z-algo? Let's see, CP algorithms, z-algo. I forgot. Like it's been some time. I've used z function. Hmm. It's an array of length n where ith element is equal to the greatest number of characters starting from position I. Okay. So A matches with A, so that's why it's 2. Is it useful? I don't think so. Okay, should I just go for hashing? Yeah, I think so. Okay, cool. So use this hashing implementation. Hmm. What about these two? I'll Yeah, you can just put them in the main method. The only issue with hashing is this might clearly um, because hashing is actually slightly expensive compared to your normal KMPs in z-algo. Yeah, I think I'll take this risk because I have no other clue like how I can proceed here. Um, Correct. So this is the pre-processing part. Now I have both my powers. Now what do I want to do? Now for every I have done question like this before, if I remember correctly. Hmm. Okay. Point I equals wait, I equals 1, I less than n, I plus plus. Long answer starts with n because I'm not doing it for zero index. Okay, L equals I, R is equals to n minus 1. Hmm, yeah. While L is less than equal to R, plus R by 2 if same. So I'm talking about hmm, from I to mid. I equals to mid, L equals mid plus 1. Otherwise, if I'm not able to do that, then I would say R equals mid minus 1. Okay. Now I need to write this function. And I think this should also take, okay, I'm not really sure like what it should take. So, yeah, vector. Okay, so it's a string, and the starting position, which is the L, and the ending position, which is the R. Hmm. Length is equals to R minus L plus 1. This is the length we're talking about. H1, I think I need to pass both these P1 and P2. Let's pass P1 and P2. Okay, so a hash one should be, hmm, it should be what? It should be h of. So if I'm saying length equals to 1, if I'm saying length equals to 1, and I also need to pass pair int, int hash is equals to, what is the method? Get hash of string s. Okay, I need to pass this hash as well. Here. So it's a vector string, no, vector of pair. Okay, I need to replace all these integers with long hash. Okay. I need to do this, and hash is one base. So okay, so I'll say s of length times p1 of nothing. Okay, okay, I'll have to do that because p1 of r. So when I'm saying let's start from one, p1 of l, I think. Hmm, this should be good. Similarly, the second hash, this should be h2, and this will be p2 of l, and this is mod 2. Correct. H1, H2. Similarly, I'll hash for the other string, which is the other substring. It's 3H4, and that would be slightly tricky. That would be R plus 1 minus S of L. Is it L? Yeah, it should be L. Plus mod. I'll do a mod as well here. Hmm. And do I need to raise it to any power? No, I don't think so. Yeah, I need to raise it to some power. H1 equal to H3, and then H4, sorry, H2 equal to H4. Issue is that this is hashing and there's no guarantee it's going to work. Okay, and I'll also have my index set to what? -1. If idx not equals to -1, then I would say answer plus equal your idx minus I plus 1. And here come your answer. That's it, I think. P of n plus 2. What's the issue? Hmm. Okay, let's make it a vector. P of n plus 2 comma 0. Let's convert this to long. This is P2. And what else? Yeah, I need to make all of these long. This is a long. Um, this, these are also long. That's okay. This is a S. This should be hash. Okay, and this should be dot first hash of length dot second. This should be hash of r plus 1 dot first hash of L dot first. This is hash of r plus 1 dot second hash of L dot second, I think. Okay, this should also be similarly a long. Hmm. Now I'm missing anything. Answer is also long. Let's see. Okay, forgot the semicolon, semicolon. These are now vectors. Vectors, vectors, long, long, two. And this is also by reference. Anything not passed by reference. Okay, it's not P1, it's simply P. Again, am I not passing the hash? Passing, this should be same type. 9 and 14. Oh, this seems to work. But will it work? I'll just go through it once again. Um, so this seems good. So you find out hash of both things. Yeah, I'm slightly worried. This might, this might be bad. Okay, let's try this case. This is a run code. Okay, now I don't even know if this is correct or wrong. I'll just make a solution. Oh, this works. Cool. Yeah, I was not expecting for this to work, let alone in the first try. But yeah, this seemed to work. Let's see, where are we? It seems there was an easier solution to this because people have done this in like 3 or 4 minutes. So yeah, there should be some z-algo or something direct implementation of that, I think. I've done this in 21 minutes. So yeah, um, not really sure. Maybe out of top 100. Cool. So I'll go through the problem, my solutions again. So the first problem, basically you're given two numbers, and you have to form the second number from the first number. Uh, the operations you have is you can flip, the bits in this number. So the binary of 10 is actually 1010, and binary of 7 is this one. We want to form this number from this number, and we can flip bits from 0 to 1 or 1 to 0. So yeah, this is a standard problem. You just take the XOR of the two numbers. So XOR will give you bit one at those places where the bits are differing. So it's 0 here and it's 1 here. So in the result, you'll get a 1. It's 1 here and 1 here. So you'll get a 0 in the result when you do the XOR, right? So XOR will give you like at what all places you have different bits. And then you can use this inbuilt method, which tells you how many bits are set in this result. So yeah, that will give you like how many bits were differing between these two numbers. So that should be your answer. Cool. So after this, next problem was okay. So yeah, this was also a fairly easy problem. So you're given n numbers, and so what happens is in one operation, every two consecutive numbers, they get added up, and you take the last digit of that number. So what I mean by the last digit, so in case like 7 and 9 are adding up, you'll have a 16. So you just take a 6, discard 1, correct? So yeah, that's what this means. So you take modulo by 10. So yeah, in every iteration, you'll see that for every consecutive number, I'm losing one number. So we had 5 here. In this iteration, we'll have only 4. And then 3, 2, and finally we'll have only one number. And this last number or digit will be our final answer. So coming to the solution, my approach was like we had only 1,000. array length. So we could actually do a brute force. We can do a n square approach. So what I'm doing is I'm simulating every iteration. So I create a temporary vector and loop over the current vector, current array, and then yeah, just populate this new vector and finally replace my uh, first vector with the second vector. And this will happen as long as I have more than one element in my first vector. So this will break when when I reach this stage of the last eight, and I simply return that element that would be b of zero. So yeah, this was also like brute force. No special any elbow here. The next one. So here you're given a string s, and you have to find out the number of ways you can choose three characters from this in such a way that no two consecutive characters are same. So basically, what I mean by that is if you choose, let's say, if you have a string, let's say something like this, you can choose first character one. Now you cannot choose this one because you already chose one. So if you choose one, you'll have two same characters. So after the one, you can only choose a zero. So you can choose this zero or this zero, anything. And after you choose, let's say this zero, you cannot choose a zero again because in that case you'll have two consecutive same characters. So yeah, there are only two possibilities for this, which is you can either have this kind of subsequence or this kind of subsequence. So you have to count the number of subsequence of these two patterns. Yeah, so what I'm doing is I'm looping for the second character, which is the middle one, and then I'm finding out how many zeros or ones are before it and how many zeros and ones are after it. So that's my basic approach. So I pre-calculated a prefix number of zeros. So at any point I can just tell how many zeros are there in the prefix, and I started looping from the backside because I'll make use of this prefix, and I also maintained a new variable which will tell me how many zeros are there, in the suffix of I. So if the current character is one, I just check how many zeros are to the right of it and how many zeros are before it. So yeah, that many number of ways I have. So if there are three ahead and let's say two zeros before, so that will be three times two. So we have six ways of choosing, a zero from front and the back. Similarly, this is for the one case when my current character is zero. I need to find out how many ones are before me, how many numbers are after me, after the current character, and how many numbers are before this character. You take a product of these two, and then yeah, that should be your answer. And finally, you just sum up all these for every character. That is your final answer. This is also fairly simple. Last one, yeah, I think I overdid this problem. Um, there should be, I'm sure this should be something which is very trivial. It's something like z-algo or KMP. I think so. It should be something like that. So you're given a string s, and for every suffix of s, for every suffix, you have to tell how many characters in that suffix from the start are matching with the actual strings, starting characters. So if you take this suffix bab, in this bab, so that is matching with this bab, right? So for this suffix, answer would be three. So you have to do this for every suffix, and you sum up all the answers. So I used hashing here. So you calculate the hash of the string. I used two different prime numbers to calculate the hash. So, just to avoid the collision, the collision probability. Yeah, use two different prime numbers here as well, 31 and 37. And finally, what I'm doing is for every suffix, I'll have a binary search. And that binary search, so what I'm doing is, just for an example, let's say right now I'm testing for this suffix, that how many, not this one, let's say this one, that how many characters are matching with the actual strings prefix. So in fact, the answer is AZB. AZB, I think that's the answer. This should be the answer. That is three characters. So the way you do this is you'll binary search over this range L2R, and for every so this is my current L2R. So my let's say my mid when I choose my mid, this is the part I'm looking for. So I'll say, is this the hash of this substring? Is it present in the beginning? I'll say that it is present. That's what my this function does. This just takes um, this just compares both the hashes. The hash of the beginning of string and hash of that particular substring. And if they're equal, it just says they are same. And if they're same, I try to increase my left pointer. And finally, I just increment that, the number of characters which are matching. Yeah, this is like, I think this is overkill for this problem. It was not required, but because I can just see like people just finish this contest within 5 minutes. And there are many people like who did it in 10, 12 minutes. This is like, um, so I was pretty fast in the first problem, second as well. I was slightly slow in the third one and very slow in the fourth one because I didn't uh, use the, I think, intended approach, like how other people are doing. Cool. So, yeah, I think the final rank is 115. That's it. Yeah. Thanks for watching.